Hello everyone, today we have 4 similar looking questions, but their end results are all different. Now we have a ln expression, an algebraic expression, a sine inverse expression, as well as a tangent inverse expression. Now the intent of this video is to show you what technique to employ for each of the different scenarios to get the answers that you want. Now for the first case, the first thing to do is to look at the denominator. Now ask yourself, does it have a power of 1? Now if it does, differentiate the denominator and check if the derivative is similar or close to the numerator for further manipulation. Now to explain what I mean, differentiating the denominator here gives us 9, which is a constant. And the numerator is also a constant. Now thus we can manipulate the numerator to give us a 9 by multiplying 9 on top and to multiply 1 over 9 on the outside of the integral to make things equivalent. And this will give us a ln function as the end result. Now an integral will become a ln function if the numerator is a derivative of the function of the denominator, provided the power is 1. Now check out the formula over here to illustrate what I've just mentioned. Now in the second case, what if the power of the entire denominator is not equals to 1? And in this case, it is a half because of the square root that you see. Well, if there is a square root and there is a term in minus x squared, it could either give us a cosine inverse or a sine inverse result. But what we know is that in order to get a cosine or sine inverse, this has got to be an x squared, which is not the case. Now therefore, it doesn't give us a cosine or a sine inverse. Now we can then use this formula to help us. We differentiate this expression to give us minus 9, and to make things equivalent again, we multiply 1 over 9 on the outside of the integral. Now at the same time, bring up the denominator to a linear form to get 4 minus 9x power minus half. Notice that 4 minus 9x is like an fx, while minus 9 is the f prime x of the original fx. Now immediately what we can do is to add 1 to the power and divide it by the power and minus 9 plus c. Now it is actually the reverse of the chain rule in differentiation. Now very quickly we will then have this expression over here, minus 2 over 9 square root 4 minus 9x plus c. Now in case number 3, what if the power is not a 1 again, but there is a square root and a term in negative x squared? Quite similar to case number 2 previously. Now again, this is a great clue to tell us that it will probably give us a sine inverse or a cosine inverse as the result. It will give us a sine inverse in this case, for the fact that this is a positive integral. Now let's manipulate the denominator by factorizing 9 to make the coefficient of x squared a 1. The idea is to make the format similar to the formula over here. And let's try to make this term an a squared by square rooting whatever terms within it. Next, all we have to do is to extract 1 over root 9 from this integral, and we are very close to the final answer. Now remember to take the reciprocal of 2 over 3, which is 3 over 2. Now this will give us 1 over 3 sine inverse 3 over 2x plus c. Now in case number 4, we have the power of 1 for the entire denominator, and it does seem like it's going to give us a ln expression again. Now if we can try to differentiate the denominator, it gives us 9x. But look at the numerator. We can introduce a 9, but we cannot simply introduce a variable x. So this doesn't give us a ln result, but it gives us a tangent inverse instead. Now simply because of 3 unique clues. Number 1, the entire power of the denominator is 1. Number 2, there is a positive constant term over here. And number 3, there is a term in positive x squared. So this will give us a tangent inverse result. Let's bring up the formula over here so that we can be very clear on how we can work towards the end result in mind. Now firstly, make this coefficient of x squared a 1 by factorizing 9 from the denominator. Now extracting 9 from the integral, we will also try to square root this number and put it in this format, which is 2 over 3 with a square over there. Immediately, as this takes the format of this formula here, we will reciprocate 2 over 3 and multiply it with 1 over 9 and write tangent inverse with that 3 over 2 multiplied as well with x. Now, just to give you an information over here, these formulas are actually found in the mathematical formula number 26. If you are not sure, you can refer to it again. Now, simplifying further, this will be our final answer. Now, I do hope you are clearer with getting the various integral results from these similar looking questions. Remember the guiding clues over here for the various cases, which will help you get the results that you want. Thank you so much for watching, and if you have any questions or comments, do leave them down in the comments box below.